So we left off, we were talking before, well, I guess actually last week we did meet via Zoom, and we were talking about exponents and certain properties of exponents and powers of things, 3 to the 10th, things like that, 4 to the third. And now what we can talk about are actually powers of 10, because 10 is very interesting. 10, whenever you multiply it to itself, just creates more zeros. Dividing by 10, multiplying by 10, at the end of the day is just about moving a decimal point. In fact, the exponent on a 10 can tell you how many times to move a decimal point if you are writing numbers in scientific notation. So for instance, 10 to the 9th is going to be a 1 with 9 zeros after it. Tells you exactly how many zeros happen after it. 10 to the negative 9th is interesting. It tells you how many total decimal places will happen after the decimal point. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And so positive and negative powers of 10 work differently. Keep in mind, raising 10 to a negative power does not make the power or the actual number itself turn out negative. Remember, it's just like you're dividing by 10 9 total times. So that's a common misconception. Scientific notation, then, is going to be a new way to write numbers. What we can do is scientific notation. Scientific notation is a useful way of writing really large numbers or really small numbers. Numbers that are huge, very large, things like the national debt, the national GDP, gross domestic product. Really small numbers, numbers that start off with a decimal point and then go out to a lot of decimal, they have a lot of zeros, and then you start with a number. That's also something that's useful to write in scientific notation. You can do this for positive or negative numbers. It does not matter. The way we're going to express numbers in scientific notation, you're going to have some number A, which must be greater than or equal to 1, but strictly less than 10. So it's got to be between 1 and 10. It can be 1 itself, but it cannot be 10. And then it's that number A times 10 to the nth power, where n is basically the number of decimal places you have to move the thing. So how many of you have seen scientific notation before? How many of you have dealt with it, worked with it before? It's a pretty simple application of certain exponential properties. I'll give you all a second to write it down. Now, what's really interesting is that the power on the 10, the n, if you will, is going to dictate whether you're dealing with an incredibly large number or an incredibly tiny number. If n is positive, if n, the power of 10, is a positive number, you're dealing with a number that is actually really big usually. If n is negative, you're dealing with a really small number. So let's see. If you have n and it's positive, then to convert from scientific to decimal notation, you're going to move the decimal point in A to the right n places. So positive n equals really large number. If n is negative, you're dealing with a really small number. So negative n equals really small number. A number that's really close to 0. In fact, it's telling you how many places to move the decimal point, and then the sign of n, positive or negative, tells you which direction to move the decimal point in, to the right or to the left. So for instance, 1.375 times 10 to the 10th. This is our number A, 1.375. This is n, the power. So it has a power of 10. It's just a coincidence that it's also a 10. Is 10 positive or negative? Positive. So we're going to take 1.375 and we're going to move the decimal point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places to the right. And I know it's to the right because the power was positive, so I'm talking about a really massive number. The number has to get really big. What do I do with any of these spaces here? Exactly, because I'm multiplying by a really large power of 10. So it's 1, 3, 7, 5. And then there's 1, 2, 3, 4, 5, 6, 7 zeros that go after that. We put the commas in the appropriate places. So really, 1.375 times 10 to the 10th is really the number 13,750,000,000. That is an absolutely massive number. It's huge. Huge number. So if you're starting with a really large number, or rather if you have a positive power on n, what you're dealing with is a really large number. If you have a negative power on n, say 7.29 times 10 to the negative 6th power. Exactly, and it's to the left because you know if it has a negative power on the 10, then it's a really tiny number. You can't, if you move it to the right, you're making a large number. So you move it to the left. So you don't have to remember which way do I go, left or right. It's just kind of obvious when you look at the exponent. The exponent is negative. That means you're dealing with a small number. So you're going to be moving it to the left 6 spaces. So 1, 2, 3, 4, 5, 6. That's where the decimal point goes now. We fill in that with zeros, so it becomes that, which again is a really small number. And sometimes people like to put a 0 here before the decimal point. It doesn't change the value of the number. It just to accentuate the location of the decimal point. So it's pretty clear that we're going to be dealing with really massive numbers and really tiny numbers in certain contexts. For instance, here's a really massive number you might deal with. This is current. The current stimulus plan that the U.S. government wants to pass and is likely to pass in the next couple of weeks here is for $1.9 trillion. So it's 1,900 billion, millions, thousands, hundreds. That's literally how much the next stimulus plan they're talking about. I should say the likely price tag of the newest stimulus plan. Now, I'm not criticizing it. I'm not saying anything about it. This is just a fact. That's how large it is. And if you want to express that in scientific notation, because look at that. That thing is just a mouthful to say. I mean, they don't even write, when you read news articles about it, they don't write this number out. They say 1.9 trillion, don't they? So if you wanted to, let me double check that that's right, because it looks massive, doesn't it? That looks like an absolutely huge number. If I remember correctly, 14 trillion seconds, if you go back in time 14 trillion seconds, you go to the time when humanity was living in caves before we knew how to read or write. So trillion is a massive, it's huge. But yeah, 1,900 billion, your millions places, your thousands, and yeah, your hundred, tens, and ones. Yeah, this is exactly what it is. If you want to express that in scientific notation, you need to move the decimal point until your first number is between 1 and 10. So you clearly have to move the decimal point 1, 2, 3, 4, 5, 6. I'm doing a terrible job with that. Hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 places. Now, you might say you moved it to the left. Don't think of it like that. Just tell yourself it was 12 places. And then is the power of 10 going to be positive or negative? Positive, because you were talking about a really massive number. So the next stimulus plan is 1.9 times 10 to the 12th dollars. That's a lot of money. That is a lot of money. But it is an unavoidable truth here. Again, I almost don't believe it. I feel like I've put too many zeros on it, but that's what it is. I've checked it. Where you might talk about tiny numbers, that's a little bit different. You might want to, you're tempted to say something involving molecules, maybe. If you've ever heard in chemistry of, I think it's called Avogadro's number, it's like 6.0233 times 10 to the negative 23rd. I don't remember that off the top of my head, but so if you're talking about the number of molecules like in your fingertip, that number is probably hilariously massive. So if you want to think of something to express the size of a molecule, perhaps if you looked at the radius of certain molecules, in other words, if you were trying to actually measure it, well, let's see. Let's see if I can find an interesting example. Okay, so you're going to be somewhere on the order of this is called the, or this is the units that atomic nuclei are measured in. They're called picometers, and each one of them is 1.0 times 10 to the negative 12. So if you want to talk about really tiny numbers, that would be so what they call a picometer. 1 picometer is equal to that many meters. Now a meter is something looks about like that, roughly 3 feet. So a picometer is tiny. It's absolutely just, you can't see it with the naked eye. You could not see something that is 1 picometer long with your naked eye. It's just not going to happen. So that's why molecules are just absolutely tiny. And it is why for years and years, humanity did not know why we were getting sick, because they didn't know anything about bacteria, because guess what? They couldn't really see those things. We didn't have the technology to even be able to fathom the idea that there were tiny little microbes swimming all around us. So just some interesting ideas. But yes, this is a common place where you're going to see scientific notation is if you go into the sciences, specifically biology. Biology is really big on that. So here's a nice, you don't have to copy this down. Here's a nice big long explanation for how you convert from regular decimal numbers into scientific notation. And it's not particularly fun to read. It's kind of a long, dry read. So don't think of it too hard. Think of it as, all right, I'm starting off with a really massive or really small number. I need to get the number to where it's between 1 and 10. I need to figure out how many times I had to move the decimal point. I need to figure out if I started with a really large or a really small number. So again, if you start off with the number maybe like that, 13,570,000. Certainly nothing to sniff at if you're talking about dollars. Even if you're talking about cents, that's 135 grand. We know we're starting with a really massive number. So whatever the power is on the 10 is going to be a positive number. Now you don't have to put the positive sign, but you should know that already. So here's where the decimal started. You need to figure out how many places you have to move the decimal point so that your first number is between 1 and 10. So you got to get the decimal point right here. So that's 1, 2, 3, 4, 5, 6, 7 places. It's going to be 1.357 times 10 to the 7th power. And you know it's positive 7. So they always try to get you to remember which direction do I move the decimal point in. That's not gonna, you're gonna mess it up, make a mistake, get it backwards. I promise you, it's easy to do. So just tell yourself, do I have a massive number, which is positive powers on the 10, or a really tiny number, which is negative powers on the 10? If you're talking about a really tiny number, like that. Again, you know you have to express it in scientific notation, so you know it's going to have a negative power. Once you know that, don't worry, am I moving it to the right or left? Don't think of it like that. Just move it until you get the decimal point snug to where your number is going to be between 1 and 10, which would have to be right there. And then you tell yourself, I went 1, 2, 3, 4, 5 places. So it's got to be 4.21 times 10 to the negative 5 power. So again, converting from decimal notation and into scientific notation is really not going to be so bad. 4,600,000. 4.6 times 10 raised to the 6th power. Again, it's because you start with the decimal point right there. You know it's a massive number, so it's going to be times 10 to a positive power, and you're going to move it 1, 2, 3, 4, 5, 6 places to get it there. This, you got to move the decimal point 1, 2, 3, 4, 5 places. It was a really tiny number, so it's 10 to the negative 5th. It's 2.3 times 10 to the negative 5th. Any questions on that? Questions, comments? I think that's a good stopping point for today, simply because, like I said, I wanted to have the final exam Thursday because I knew we would run out of material. Let's save this for tomorrow, just so we have something meaty to sink our teeth in. And then tomorrow we'll also talk about when is our final exam going to be. Also, we're going to need your calculator soon. You're going to need your calculator. Remember the type of calculator you want to use. This is going to be for the 1332 portion of the course. You can't use it on the 0332 final exam. But there's two types of calculators you'll want to focus on. The less expensive method, still good. The TI, the TI-30X2S scientific calculator. Don't get caught up in this mumbo jumbo here. It's just the standard scientific calculator. We sell it at the Weatherford College bookstore. It's Walmart, Target, everywhere is going to have it. Yeah, I think it's about the same price on Amazon as anywhere else. And then you have your TI, you can do the TI-83 or the TI-84 graphing calculator. This thing is a beauty. This is a wonderful, wonderful calculator. Let's look at a few pictures of this real quick.